Hello everyone. I hope everyone have a great weekend. In previous lesson, we mentioned several topics: reference angle, angle rotation diagram, convert degree to radian, those kind of thing. And I keep telling you, all these topics are actually serve the final thing, which is trigonometry function. The the one topic we're going to spend a longer time to focus on. And today we finally come to touch this topic. So let's check. In order to introduce trigonometric function, we're going to have a quick review. Trigonometric function or trigonometric ratio, as you learn in geometry or even algebra, we mentioned something. This is not brand new here. Trigonometry ratio, trigonometry function is actually coming from trigonometry ratio. If you remember that, we actually use SOHCAHTOA to memorize this ratio. So we're actually gonna use this one as a foundation, as a very basic one formula we're going to use and extend it in a larger area. So let's quickly review what actually does that mean. So when we define or when we use a trigonometry ratio, the very first thing is we need to identify the opposite sides, the hypotenuse, and adjacent side. But how do we use it? So we actually use a given angle. So in right triangle, because before when we define sine, cosine, we actually use right triangle here. So we are going to review this one. So in right triangle, we use a given angle. For example, a given angle, this one is a Greek letter theta. So we use theta to label the side standing in front of the theta is opposite, meaning opposite side of the angle. And the longest one, and you can also see the opposite side from the right angle here, which is actually hypotenuse. And the right side, which is one part of this angle, we call adjacent. Okay? So that's how do we label three sides. And the sine, when we write down it, S is actually S and E. Cosine is COS and E. But to save our time or to save it to write in a simple way, we just use sine, and we always follow the angle, sine theta, which is opposite over hypotenuse. So opposite over hypotenuse. And cosine, we do not write the whole thing. We write down the cosine and follow the angle. And is adjacent, which is adjacent over hypotenuse. In the future, we are going to talk about the tangent. So today we'll only focus on the sine, cosine. One thing, just want to remind you again, every single year when I teach this topic, I keep reminding my student, don't call this sine cos. This is not right away. Even you think, oh, this is sine, this is cos, but this is not how we call these functions. This is sine, this is cosine. Okay, so next we are going to extend this definition. Please keep reminding this. Keep this in your mind. So we are going to extend this definition to random angle. Random angle is actually still going to be defined by using, let's see, we draw a random angle here. In a random circle, remember it's not a unit circle. If we don't tell you this unit circle, do not say that. So we just gave you the circle, but the center is actually our origin. This circle has a radius r, and the terminal rate for this angle, initial is always x-axis. Terminal rate touch the circle at this point. Let's say x and y. These coordinates, again, this is random circle. It's not in unit circle. So how do we define this one? We are going to use coordinates. This one, and draw the triangle here, the right triangle. And according to the definition, sine theta is going to be the opposite. So how do we define the opposite? The opposite side is going to be this one. And according to these coordinates, this distance is actually 1. Let's use a different color. This distance is actually y. And this distance, let's use a different color. This distance is actually x. That's actually how do we read the coordinates. The horizontal distance here is x, and this is y, so xy. And this is exactly happened to our opposite side. Let's use this one. Opposite side and adjacent side, right? So according to the definition, we know sine is opposite over hypotenuse. So opposite, which is y, over hypotenuse. What is a hypotenuse here? Yes, it's a radius. So in random circle, we use the coordinates of the angle over the radius, and then this is sine. So if you remember that last week we actually talked about the coordinates, that's exactly why we keep talking about coordinates, because we are going to use the coordinates to define cosine sine. Okay, next is cosine. So cosine, I always mentioned, is adjacent over hypotenuse, so that's why it's x over r. See? That's why we talk about the coordinates, because we are going to use it to define the function. So some student might mention, hey, what if the angle is, the terminal ray is not in the first quadrant? What if even the random one? So same thing. So let's draw the random one. So let's say initial ray is here, and let's draw this one. So how do we draw this? Again, we focus on the terminal ray, where terminal ray intersect the circle, the coordinates as x, y. So this time I'm going to draw the triangle here. Even this one is whole theta, but we're going to use this right triangle here to define opposite and adjacent side. So opposite side, again, we use this piece of angle to define. So if you remember it carefully, it's actually reference angle for this one. See, everything is connected, right? So we use this angle to label the opposite side, which is actually the distance y. And this distance, let's use a different color, is, we know it's adjacent, but it's actually x, right? So this sine theta, we are going to use the distance of the y coordinates of this angle over the radius r, because this is a circle, the distance of the radius, and the cosine theta is going to be x over r. So no matter how do you draw the angle, we always use coordinates. We always use the coordinates to define this angle here, and that's it. That's how do we define this in a random circle. But some student might say, hey, you mentioned the unit circle before. How do we use it? Very good question. In unit circle, the only difference here is we still draw a random angle. The only difference is the radius of the circle is not just r, we know that is 1. So if we know this is x, y, so we still use the same definition here. Sine theta is y over r, but we know the radius is 1, so that's why it's 1 y over 1, which is y. So cosine theta, some students already mentioned, probably already figured out. The definition, as we mentioned before, is x over r. The x is actually coming from the coordinates of this angle, x over r, and is x over, again, this is unit circle, so it's 1. So x over 1 is x, and that's it. That's in unit circle, so I'm going to highlight this part. In unit circle, sine theta is the y coordinate, cosine theta is x coordinate, but do not just use it in a random circle. they must be true in a unit circle. Okay, so that's how do we use the circle, the coordinates of the angle to define sine and cosine function. That's exactly why last time we actually introduced coordinates of the function of the certain angle here. That's very important because we are going to use them to define sine and cosine. In next video, we are going to check some examples to reinforce this idea to make sure you understand in a better way. Okay, see you soon in next video.